So discussing about the dynamic programming, we are telling it is a kind of the technique like the divide and conquer principles. Okay. And how it uses, like it uses the results obtained in the previous step to get the final answer. What is our idea? Our idea is to the idea is to use the we have to use the sub solutions obtained in solving larger sub problems. Solving the larger sub problems. Again, this program is different. This program is different from the procedural or the object-oriented. These principles have previously what is object-oriented programming, what is procedural programming. It's a different approach. This is one kind of difficult also approach because problem dealt with the we have to go in different way. How you can say generally what happens, and this dynamic programming might appear similar to the divide conquer approach, but there is a fundamental bit differences in two approach. It may similar to divide conquer, but there is a simple differences. What is that? Both and divide conquer approach, that is dynamic programming, requires division of the problems. Both, if you will consider the divide conquer also, divide conquer, divide conquer, or you consider the dynamic programming, both considers your division of the problems. Consider the division of problems. Division of problems will be divided. Okay. In the former, the subprograms are independent, but in this case, what happens? That in divide and conquer, it will be the independence. Okay. But where is in the latter, this is not independent. So in that case, we can say dividing the problem, we can make a classification that is dividing the problem, into sub problems is it is under two different ways. You can say this is done also through the divide conquer also. This is done on the divide and conquer, and it also same thing happens in case also dynamic programming. Okay. The division happens, but here what happens in case of the divide and conquer, we are telling it is of independent. This is all are independent sub problem, independent sub problem. But here it will be overlapping sub problem, overlapping sub problem, overlapping sub problem. This is the dynamic versus your, we can say this is the approach. This is between, I can say the dynamic versus the divide and conquer. One thing also happens that we can say the dynamic program generally uses the bottom-up approach. The dynamic programming mainly uses mainly of which one? the bottom-up approach. And anybody say bottom-up approach used in which case? Bottom-up approach. Anybody remember where we are using the bottom-up approach? Where we are using the top-down approach? Can anybody say? For the divide and conquer, you just your top-down approach. Any answer from anybody? You just top-down approach. Can anybody say? Anybody can say or not? In C++, we use the bottom-up approach in object-oriented programming, but in C procedural language, we use the top-down approach. So what happens in this also, what we do in data mining, this is theory I'm telling, this is the concept, then we'll go for the major issues. Okay. In dynamic programming, what we do? The use of the calculated value, the use of the calculated values, use of the calculated values at a later stage. Okay? Later stage is facilitated by storing the calculated values in a table. How you do? We'll take the LCS problems for solving these. We can show you how it is storing the calculated values in a table. Paradigm therefore requires memorization. We do not say the memorization, say, but the algorithm will call the memoization. Okay. This therefore this requires memorization, but the algorithm will discuss memoization. Okay. Therefore, it requires, because since we are storing in a table, it requires the memorization of the things. It should be remembered. Okay, it is the memorization style. Okay. This approach can in two ways. It can also work in bottom up, can also work in top down, we'll see. But in bottom up approach, the solution starts. The basic input values and builds of the system. We'll see how it is happening. So for implementing the dynamic approach, how will it implement? How to implement the dynamic approach? Implementing dynamic approach. I will implement it. Generally, the development of dynamic programming problem requires the following steps. What are the steps? It requires the main steps, we can say. First of all, conversion of a given problem into a search problem. Whatever problem will be given, it should be converted to a search problem. So search from a larger search space. That should be searching from a large, because if the space is widened, then it will be very easy for searching in any kinds of the elements. Okay. Although there will be overlapping also. So what will happen? So in case of the conversion of the given problem into a search problem, that will be from a larger space area. Second, what we will do? The search space is generally segregated into various subproblems. It will be segregated, divided into subspaces. This requires the development of partition algorithm. You know what is partition algorithm? How we have done? Okay. Developing a partition algorithm is also a kind of recursive algorithm. Okay. Then what happens in the final step? The recursive calls will be characterized. So first, how we say, we can say here what happens here conversion, or we can say convert the given problem, convert the given problem into a search given problem into a search problem. Okay. So this totally we can say this step will be called as your, it is called your conversion. You're gonna count about this method are gonna count about. It's called, you can say that conversion. Conversion is the step we discussed. Okay. This method will say the conversion. Conversion. And after that, from the conversion, what we will do, it will go to develop a partition algorithm. How will the partition develop the partition algorithm? Then we have to have develop, okay, develop, how we can say, okay, develop a partition algorithm. Develop partition algorithms. Okay. Then that means what we will do, that means here we can say what we are doing here. Now, in case of the dividing the forward and developing a partition algorithm, what we do really in this case we will do, that is called the divide the problem in subspaces. So partition algorithm says that what we are going to do now, we have to divide, we have to divide the problem, where the problem in a subspace. The step. After this, what will happen? After doing this thing, what happens? We have to table fitting. Regarding what we are telling, that is called recursively call. We go for recursively call. Recursively call. Theory behind it. Recursively call and characterize a non-recursive procedure. These total methods we are telling, this is called the method. What we do here, this is called a table fitting. It's the most important method. This is generally called a table fitting for memorization. It's called. So this is the implementing the tricks. Implementing your dynamic approach. How will you implement this? So this is the concept behind it. How can implement your what? That is our dynamic programming. So mainly what happens? So this implementation, the use of this dynamic programming can easily understood through an example of that is called the what? See, is it okay? Any doubts up to this? This is the theory I'm telling behind it. Let us clean it. So what will happen? Now overall this, am I audible?
Yes, sir.
Yes, sir.
Again, sir.
So what happens now? We will take the example of understanding this concept. This dynamic approach or this dynamic programming approach, what we told here, that is the convert the given problem into search problem, that is called the conversion, then developing a partition algorithm, that is the divided problem into subspace, then recursive calls, characterization of the non-procedures, and then called the table fitting. What will happen? So it can be, what we can say, it can be understand, so it's called LCS. LCS, that is important. What is LCS? Called the longest common subsequence. Okay, LCS. So the LCS, that is the longest common subsequence. What By taking this, we can understand what is the dynamic approach. For the dynamic mainly, we can say there are many approaches that another more will discuss in our course, but the traveling salesman problem is also there. But one of is there that is called the longest common subsequence. Okay. So this can be understood through the LCS, that the longest common subsequence problem. Okay. Now let us see. Let's say given, what is this? Given two sequence, that we can say given the two sequence is like let x starts from 1 to n. This is 1 to n. One sequence is there, okay, and another sequence, let's say y is there, that is from 1 to, that is 1 to n. This is the two sequences are given. One is your x, another is y. Our objective is what? Objective find the LCS, find the longest common subsequence. Okay. But commonly to common both of which x, and we have to choose a LCS that will be common to both x and y. So if x is a sequence, that will y is a sequence, then we have to choose a sequence that will be present in x as well as in also y. Let us take a simple example to understand first, then we'll go for the algorithmic issues. Let x, okay, x is just there. So we are taking a sequence. Let we can say a, then b is there. We can say let c, let d, let suppose x there, a is there, one other is b, c, another is d, a b c, b there, this is b type, a b c, b, another is d, another is also we can take a, that is b. This is a sequence of x. Let's y is another sequence. So let y gives the b, then D, then suppose C, then it is A, then suppose B, then it is A. So among these, what happens? We have to choose a sequence that will be present in both common to X as well as the Y. So how we can start from a single letter, but single letter doesn't, we cannot say a sequence of a sequence, that is not cannot be called as the longest sequence, subsequence. Okay. So let us start with the two letters, what subsequence of length 2. So I can say AB is yes, but subsequence of length 2, because we can say, how you can say AB is a subsequence? Very simple, you can say that this is your A is present from here proceeding AA, then BB. So AB is present in both the case. So AB can be a subsequence. Yes or no? So it is a subsequence of length 2. Similarly, if we choose more also, there will be many numbers of subsequence. But we need a one. We need a one that should be the longest. That may be many more of the sequences, but we have to choose a longest, a one. Okay. So let us then to choose further. But length of 3 sequence. So can I choose from this B, C, B? The subsequence can be chosen. From this also I can choose this BCB. How can choose this BCB? Okay, just you can choose B, then it should be C, then it should be B. Or this is DC. How you can choose? In which you will choose this longest sequence? You can choose like this. How? This is let B. This is C. Then this. Okay. This is a subsequence with length. Understanding it or not? Similarly, I can go for a subsequence of length 4 because I need the length to be more longest. Let's have choose for the 4-letter sequence that I'm choosing a sequence. Let's say BCBA. It can be possible. Option B, C, B. I can take this also. This is the BCB. Understand? This is a subsequence of length how much? It is 4. It is a subsequence of length how much? This is 3. It is a subsequence of length how much? This is 2. Another can we also find? Can I take the B, D, B, A, B, D, B, A? How can say B, D, B, then A? I will find. Can it be possible or not? B, D, B, A is there. Can you find it or not? BD is also a subsequence. BD, B, then A here because you can go for this B, then you can go for D, B, D. You can go for B. That's A is there. So what happens? This is a subsequences. Sorry, BDBA is not. It is not possible. It's wrong. It is wrong. Not BDBA because it is crossing. Sequence is not correct. BDBA is not possible. Which one will say this is not possible? This is wrong because it is not cross. So we can take the sequence like let's say it will be possible BDAB. That is our length for how this B is there. It can be possible. Okay, this is the B. Yeah? B is possible. Then you have to D possible. Then S so BD AB until not B. BD AB. A is possible. Okay. B is possible. It is possible of length for yes or no? Are understanding or not? How finding the subsequences of length? Are understanding or not? Any doubt on this? Any questions? Maybe I raised also. You cannot understand. Because I am choosing the sequence, let X is a sequence, Y is a sequence. I am choosing the longest common sequence to both of the X and Y. For my longest should be the not a single one that may be more than of the same kinds of length 4 or 5, but among them there will be one is the longest. You have to choose. That means find a length, not the length there will makes many moves. There may be length of for there will be 3 strings maybe there. So that is one of I can also choose. That is the hash length. That is the hash length. That is the length. This is the approach of your for finding the longest common subsequence. There is algorithm, we will understand the algorithm. Then we will go for the memorize method that we discussed, table fitting methods I will discuss. Are understanding up to this or not? Or any doubt on this? Any questions? If anybody is not also understanding how I am finding the sequences, subsequences among this. Okay. So next we proceed for this, but we are proceeding for a algorithm approach because this is your idea is going to this. Because if you understand the algorithm, because the method is there recursively. So what is the recursive procedures that you have to understand? Without any algorithms, you cannot go further something to find. Now is let's say let us we can say there is a neighbor approach we can say. In it, let's we can go for the neighbor approach of finding this dynamic programming. I will do. Let's take a we can say the neighbor approach. Okay, neighbor approach. So what we are telling, there is a x of sequence of 1 to how much? 1 to we can say 1 to we can 1 to n. There is a y sequence starting from 1 to n. So every sequence of x, you have to check but whatever sequence is present in the x, whether that is present in the y or not. Yeah. Because in x, what you can say, what this approach says, we have to choose, first have to choose subsequence of x. We are choosing a subsequence of x. First is check. Second, what we will do? We have to check. How you are going to check? Check every subsequence of x, subsequence of x is present in y or whatever subsequence you are choosing from x, whatever you are choosing from the x, that is whether present in y or not. Then go on checking these things now. So what is the people check? What will the order of time? It will be order of time of linear time. Who can say that will be because we'll go on check each time. So it will be order of n. Okay, complexity will be order of n because there could be n subsequences. Okay, there can be n subsequences. Yeah. So if you go on checking this, you choose a sequence. Again, you'll check everywhere in this or not. So there can be any subsequence because you see we are not finding the LCS of length 2. We may find more number of LCS of 2, more number of LCS 3, more number of LCS 4. So 2 to the power m I can get. I understand it. Because not a single you are getting. In a particular sequences, we are finding more than one of same kind. So what happens? So if you check this much only, this is the order of n. What happens? So there could be what will happen? There could be we go on this, there could be n subsequences, n subsequences, n subsequences. So like that, it will be n express, n subsequences will be there. So obviously, will be exponential time of because it will make you the time complexity of theta 2 to the power n because we get the many more 2 to the power n. Okay, into we are finding for the n numbers. So it is a very typical case. If the power something in it, this is a exponential time. It is costly more. Exponential. To the power something, it will grow exponential time. It is cost effective. You can say very expensive. This algorithm will be very expensive. This will not be considered. Okay. So not acceptable. If you go on liking this, it is very expensive because it is order of the to the power m into n. Single choice that is order of n. So if you go for n times 2 to the power something, that will be very expensive one. So not acceptable. Okay. So this approach not acceptable. This approach is not acceptable. We will not prefer this one. Okay. So to do better, what we will do better, we convert or this problem. We convert this problem. Okay. Convert this problem or simplify this problem. Simplify. Simplify. Then only we can process. Because we cannot go in a exponential growth. That is not true. So we have to convert this problem. So the divides will make us simplify these problems. Okay. So how we can do simplifications? Okay. How we can go for the simplification process? Okay. So I will go for simplification. So what our objective is what? Our objective is a problem. Objective is given a problem is to find LCS between x and y because you have to find the unique, that will be unique approach for simplification. So in simplification, what we'll do? We'll do find length. Find the length of longest common consequence of the length. So for this, we have to use some prefix notations. How you can use. So length should be unique. Okay, we have that. We have to do length unique. So for this, we have to find the length of the longest common subsequence of x and y. So for this, what we have to do is we have to use some prefix. What I can say, suppose consider that I'm telling sequence is C I J is represented to Cij is the length we find. So Cij is equal to itself the modulus of, because longest common sequence we want to find. So modulus of LCA at this one string that is coming from it starts from 1 to 1 to I this one comma another way y that is given from 1 to 0 to another is this. So we want to find the what longest length. This represents your what? This represents the length. So your, this represents the length. Yeah. Because basically we will find the what we are going to find. Basically we will find the main thing is what your length will be this. How can you represent this? So basically you are looking for all ij, mainly you have to find. That means you can say basically we are looking for all ij mathematically for all ij where we find the C is equal to longest common subsequence of what? Of x, y. Full x, y I'm taking now. We are looking for this. Because you see, if this is their age, so from what one can say, then that this is a R sequence we can select starting from this one, and this is your M location. Somewhere there is I position. Let's say this is your I position. Okay. So this is may match from this 1 to I. Similarly, there will be Y. There is also some sequence that you can say it starts from also something one. Somewhere in the this is J. Somewhere is there. Then we are telling this is 3. First, we can say it is up to which we can say up to n. So somewhere this tends up to this. We are looking this. So we have to find it. So what happens? Now the theorem comes. Now we can justify this is the longest common sequence or this is the longest consequence. So we have to find this. For all algebra, we have to find CMN LCS of x1. Okay. So for this thing what happens? Now for every dynamic programming has a recursive formula. So I would say and this every dynamic programming has a recursive formula. That one we'll discuss. Now let's say that every dynamic programming recursive formula. Recursive recursive. What is the recursive formula? That is also important. Recursive formula. There is a theorem. It states this is the recursive formula, one kind of theorem. Theorem. Here, ontology. Yes, you can say C of I comma j. C of I comma j is equals to recursively it is telling C square bracket I minus 1 comma j minus 1, okay, plus 1 I minus 1 j minus 1 plus 1. Answer is if x of I is equals to y of j. If this can be happen, okay, if x of I is equal to y of j, that means c of I minus 1 and j of I minus plus 1. Okay, this is the thing. Understand? But otherwise, what will happen? Otherwise, it will be maximum of, this is the formula. Okay. Otherwise, it will be maximum of what? That will be maximum of, you can say, till maximum of C square bracket I minus 1 to j. This is one part, comma, and C of I, comma, j minus. This is maximum of this. We have to find. Okay. So if you find maximum of this, you find the maximum of this. How? Because this formula says if condition is what? Yeah, condition is x of I not equals to x of I not equals to y of j. If x of I is not equal to y. This is what we are telling the recursive formula of dynamic programming, and this represents your work. This is the length. This represents the length of the pencil. It should give here design techniques. And here is the one index less. I minus pattern. There is a one index less pattern. So if it will C of I minus 1, j minus 1 plus 1, how much? If x of I is equal to y of j. Otherwise, it will be max of Ci minus 1 or Cj I j minus 1 if it is not equal. So this is the actual logic algorithm. The question is, if you are interested, then we may follow the algorithm to prove this. If you are interested, because this dynamic approach of the algorithm, this dynamic approach gives two hallmark problems. Okay, because we will say I provide dynamic programming. But issue says dynamic programming. Okay, dynamic programming. Hallmark one. This is okay. Hallmark one. This is another one algorithm. This is for optimal substructures. Okay. So this is for optimal substructure. This is hallmark one dynamic. Another program is also there because hallmark two is given the prove this algorithms. Hallmark two. This is for overlapping subproblem. Solve this is a very, because it is a recursive solution, overlapping sub problem, there will be recursive solution containing small number of distinct sub process, sub problems. Okay. And in case of hallmark 1, it optimal solution is a problem containing optimal solution to sub problem. So it will take the time to cut the proving this. So if you are interested, will go for this. Otherwise, what comes questions in your examination, that way I can make a solution. I can solve the problems. How to find the longest common subsequences using this theorem. So what is your choice? If you are interested, then you can go and read the thing, or I will give you a very but lemon idea that how you can solve the problem. That is your choice. If you are interested, otherwise, how to solve the questions, I will do, because up to this, I don't know how far you are understanding or not. You are interested or not, how it is unhelpful. Are understanding this, what I am telling? Are you comfortable of understanding this?
Sir.
Again.
Yes, sir.
So if you tell, I will go for proving, or I just using this formula, I'll tell the longest common subsequences through the method of memorization, because I will use the word memorization. Because we have to check previous calculated value, and that is to store. Since in that cases we are memorizing, we do not have to do so. Okay, because this dynamic program has two hallmarks. That is the most important case. This is your hallmark 1, 2 cases for proving this. People are reading the questions may not come of proving these or algorithms. Very interestingness to learn also. I don't know how to learn. If you are interested, let us say I'm solving this problem, and after solving the problem, okay, then how it is common comes in examination. If you say I'll prove, then I'll prove. Okay. So let us discuss one of the example of ICS. Hence, using memorization table. Already given the concepts, I have written what is memorization. Because here you have to check the previously calculated value. Once you calculate, we do not have to again calculate this. It will only just but store. Are you understanding? So now question are we are taking question will be like this. Find the then examination questions come like this. But if I go to deep depth of this, then I'll go for solution of optimal substructures and overlapping subproblems. Okay. Find the longest subs and the longest. Let's see, yes, the common subsequent longest common subsequent subsequence. Okay. Longest common subsequence among two sequences. Sequences is what is given. It will be given A, B, C, B, D, A, B that we have taken, and there is the B in D is C, A, B. So we can go for this. Let us how can know for the technical methods. That this is the X, this is the Y. I have to find the C of IJ. Okay, of this the longest commons. So I will do this. Okay. So the method is first you have to make a table. I'll make that I'm doing that this is A and so B column of C, A, B, C, and there will be B, A, B, C, B, then I'm taking the D, is A, so, okay. Another table you have to take. So hot, check. This is 0. This is for x. Okay. This pointing to x. Similarly, there will be y. Y pointing to down. I'm writing b. First one b. Then is your d. Then it will be this method will be there. Space is not available. Some construct space problem. Is A, B, C, it is B, then it will be D, it is your A, then your B. Okay. So it's representing your X. So this is the table, this is X. So Y will be below. So now it will be first row, first column, leave. First column, so leave it. Your B, here, this is your B, then I will get B, then we get C, okay, BDC, BDC, then it is A, then you go for B, next there will be, last one is ABA. This is the complete term. So this will be, now I don't understand your table. After process. So what happens as you do, just see, you just fill up the first row, first column to be 0. Okay, we compare with this. Fill up the first column and first row to be. Not understand, you tell me. This is the method. Second is that I have to find the what else's. How will go for this? Just see. First, I'll choose this AB. I'll compare with the AB. Okay. So is A equal to B? You can see A is not equals to B because I'm comparing this. AB match করছে, it is not matching. So if it is not same, so A, B are different. Since A is not equal to B, then I have to go for what? I will go for max. Try to understand. So now what does it mean? C of 1, 1. C of 1, 1. This is your C of 1, 1 I'm trying to make is equals to maximum of what? That is maximum of C. Which one? I minus 1. That will be C. I minus 1 is what? You can say that will be 0 and 1, comma. Then will be C of which one? And it is this algorithm. I means 1, then J minus 1, 1, 0. Okay, I want to find the maximum of this. So I can find a maximum of this. So maximum C01 is how much? The maximum of this C01 is how much? 0. This is 0. This is 0. So how you are telling? You are comparing this. When you compare, you just see you are comparing this. Okay, you are comparing A with this. So among 0, 0, maximum is how much? Can I tell? 0. Okay, so what we will do? We just fill that value 0. Maximum is 0. Among them. Understanding now? Okay, this is the idea. So next what will happen? Again we will proceed to next. It is coming B. We are proceeding through X. Next coming the B. So you are comparing with BB. So now what does it mean? So BB is equal, isn't it? BB is equal. Since BB is equal, just see. Since BB is equal, what I have to do? I have to find Ci minus 1. So which question I'm choosing? Just we see. C of 2. C of 2 in X2 and in B it is 1. So C of 2, 1. Okay, is equals to, it is missing BB same. So how you find it is recursive algorithm? You just see what we are telling. So it will be C of which one? I minus 1. So it will be 2 minus 1, 1. So it will be C of 1, 0. Okay, C of 1, 0. Okay, that is telling C of 1, 0. Okay, plus 1. Okay, C of 1, 0. So now because this C, okay, it is same. Since this is same, we see this is same. So what we have to do? So previous value, we have to check for the previous value, check this previous value and add 1. So this is 1, 0. 1, 0 value is 0. So you find this. How much it will be? C10, this is C10, value is 0 plus 1. So it will be 1. We put it 1. Understanding this step? This is the memorization. Once you memorize this, the principle it will go and continue recursively. You do not have to use the formula now. Any doubt up to this? After comparing maximum this 0, next opportunity to be. So what happened? Previous value plus 1. So it is getting this second one formula. Okay, in this case, we are moving. You see. Okay, then it is going to this one. Clear? Any doubt up to this? Anybody? Any
Yes.
doubt? Huh?
No, sir.
Okay, thank you. So now you proceed to more. Next C. Okay. Anybody? C and B. Is it same? CB is it same? CB is not same. So when it is not same, what we do? We go for maximum. So the value will be how much? We can say in here maximum what? We will choose the maximum of what? Just see, we choose the maximum of which one choosing? This B maximum of 1 and this. This will compare 1 and 0. Maximum of this is 1. We have to put it 1. Okay. Then you go to B. Just see. So BB comparing is it same? So when it is BB same, it will be what? This value plus 1. Yes or no? This will be again 1. Just try to see. Okay. 0 plus 1. 1. Understanding or not? Next D. DV, just you see, I'm just remembering this algorithm. Means what is given maximum and is comparison again. So BD is same, BD is not same. So when it is not same, so maximum of what? Maximum 1, 0 will be how much? Okay. Then coming A. Then coming A with B. So this A is comparing with this B. A, B are not equal. So we'll get the maximum of this part. Not equal means we have to this value plus 1. This is 1, 0 plus 1. Are you understanding? This is see, okay. So now it is same. So when it is same, it will be but again this plus 1. So value is filled with this. Are you understanding this first row or any doubt on this? Anybody can doubt in the first row? Because this is the memorization of table. Once you remember this thing, you just fill up very simply. Okay, fine. So next we'll go for the second row. B to A. So DA are not equal. Since DA are not equal, okay, what we'll do? We'll compare this. Maximum is 0. Very fine. DV are not equal. The maximum of this it will be but 1. DC are not same, so it will be 1.
1.
Then DB it is also 1. But now DD same, it is matching. So DD matching means it will be a part. You will find part this value plus 1. How much it is? 2. This value plus 1. Are you understanding now? Okay. Then A DA is matching. DA is not matching, so maximum this part 1 and 2 maximum is 2. Then B similarly this is 2. Okay. Then C Adil value, C it is 0, it will be also 0. Okay, it will be 1. I'm just filling. Are you understanding now? This value will be how much? We can say CC matching. It will be how much? Matching. It will be plus 2. Again, this will be 2. Then it will be how much? 2. This is 2. This is also 2. Understanding? Okay. Again, A match. What is matching? What do you have to do? Plus 1. That is 1. AB. How much? It will be 1. AB equals to 1. Then this will be 2. Okay. Then this B will be 2. Then D will be 2. But this is what will do?
3.
It will be matching. 3. Okay. This is 3. You see, I'm just putting a line. Huh? Then AB not. It will be 3. Okay. Then coming B, how much it is? B will be BA, not matching. So it will be how much? Maximum 1. This will be 2. This is 2. Then what is B? It will be what? 3. Understand? Then it will be 3. Then this will be 3. And again this will be BB. How much? 4.
4.
Understanding or not? Okay. Next. What is it? AA. It will be what? Matching. So it is how much? 1. 1.
1.
This will be 2. This is 2. This is 3. This is 3. But this is 4. And this is 4. You see, 30 is my longest common sequence. I'm getting length is how much? I'm getting this longest sequence. You just imagine the length first I'm finding. What is my length? You just observe the length is that is this represents the only C of Mn because the length of Mn string we have taken, the ij data written. So this is C of Mn that is equal to fully we are comparing LCS of what? X and y, x and y. Okay, x and y. The length. Understanding now. So how much I got? This is the 4. So I use this recursive algorithm. You just see, I use this recursive algorithm. I using this recursive algorithm. I use this recursive algorithm. So it is going on. Are you understanding my points? Since this recursive algorithms is generating the longest length. First, we have find the length of the longest common sequence is 4. So this is an order. We got the length equal to 4. Then what is our objective? Then we find a LC longest common subsequence. No doubt my length is equals to 4. So I have to choose one LCS thing longest common subsequence. But free my longest common subsequence, I will find. I can go from where? I can go from anybody. I can go from. Who can say? I can go. If I go this longest common subsequence, you can say I can go from there. This is where I can go here. This is B. This is B. Isn't it? B. This is going. You can go here also. Can you say what is the longest common subsequence? Just choose. What is the longest? Just choose common longest path. This will be. This will be D. B D. Then anybody? That goes there. B also there. B. B. Then it is your C. Then it is your B. Then it is your A. The longest subsequence line. B C. You can go to the path. This can go for this. This is representing what? People moving from these. You can starting from there. Longest anywhere you can choose. This is the longest is your B, isn't it? The longest is your B or not? I find the B position, so start from B. This for is B. So next it will be pointing to what? If this is B, this line I'm choosing from here, huh? So this is pointing to what? B. So I'm writing B. Then it is pointing to what? I'm pointing to C. This is the C. I'm writing C. Okay. Next I'm pointing to what? This is the path. Path. B. It is B. Next pointing to what? Where I've started. This is A. So this is the longest. Are you understanding now? You can start from here. You can also start from here. Okay. It will go for the BDVA. BDAV. That will be a longest subsequence or not? BDVA will be a longest subsequence or not? BDAV will be a longest subsequence or not? You can tell me will be a longest subsequence or not? I will find BD. You shall see this is B. Okay, you just imagine from this far. This is B. Then this is your pointing to D. Okay, B D A. You can check for each A. B D A B. It is for this B D. Follow this path. I got one also. There will be another also. One is BCB. I got. Yeah. This works in direction. You see, I'm now from these sides. You see, I'm not from this side. Ah, it's correct. B. This is B. Ah, this point left hand. This is from A. You see, this one was A. So this is A. Then pointing to. Am I wrong? From right side that is in from the bottom of approach. This was B. this is B. B, then this is pointing to A. Then it is pointing to D, this is D. Correct. Then pointing to, you just travel this path. Okay. This path you will travel, you can find the longest. What I said. From the 4, this 4 output there, you can travel from this. This is the room from the A. Let's say this is the room from B. This is the B. This is the room from C. This is the C. This is the room from D. Getting this one. This will be. This is from B. This is from B. This is from A. This is from A. This is from D. This is D. This is from D. This is from B. D. A. In this way, you have to understand the longest common sequence. After finding the length, then we are finding the longest common sequence. You travel this path. What are given the longest? Okay. So where you have that length is given. Are you understanding now? Or any doubts on this? I hope you have understood. Okay, so,
Yes, sir.
so what is the time complexity? So if you go for the time complexity, very simple time complexities. You show there is the x is there, x of how much? 1 to m. Similarly, it will be y. So it is y to n. So that implies how much? It is m into n. This will be theta of mn. This is m times, this is n times. The complexity will be theta of mn times time complexity of this dynamic programming approach for LCS. Okay. So what we are discussing, this is what this is our, we can say, this is all about your